Okay, let's take a look at some negative exponents. So we have 5 to the negative 2 equals. Now, anytime I'm working with negative exponents, I'm going to start off with a fraction. Over. That's what over means. If someone says to you over, write a fraction over. We know what 1 over 2 means, and without the 1 over and the 2, it just means over. Start every negative exponent question off with a fraction over. I don't care if nothing ends up on the bottom, whatever. So what we're going to do is follow the English instruction in the notes. Bring to the bottom, make the exponent positive. So 5 squared on the bottom. The exponent was negative on the top, so it's positive on the bottom. Then we're just going to put a 1 on top. Not always. Circle your answer. So again, bring it to the bottom, make the exponent positive. As you can see in the notes, you've got the rule. X to the negative a equals 1 over x to the a. Feel free to write this down in your notes so you can see the exact example beside it, or just at the beginning of the chapter, the exponent review goes through all of the rules. So what are we forgetting? Obviously, check your answer. On the calculator, 5 to the negative 2 is equal to 0.04, 0.04. And 1 divided by 5 squared is 1 divided by 25, which is also 0.04. Check mark. Not sometimes, every single question you ever do. Okay, what if you have a negative exponent on the bottom? 1 over 3 to the negative 2. Well, if the negative exponent was on the top, then we brought it to the bottom, make the exponent positive. Well, now we have a negative exponent on the bottom. What are we going to do? Well, we're starting off with negative exponent, so I'm going to start off with a fraction, and I'm going to bring the thing to the top and make the exponent positive. Now, sure, you could put a 1 on the bottom. I don't like to, and I like to leave the fraction on the bottom and not care. Check your answer on the calculator. 1 over 3 to the negative 2 equals 9. 3 squared equals 9. Check mark. So the rule off to the left is 1 over x to the negative a equals x to the a. Box around our rules. So some people are going to teach you stuff like flip it. I'm going to tell you why that's not appropriate right now unless you fully understand it, where it can apply in the future, and how I'd rather you just think the English instructions in the notes. Bring it to the bottom and make the exponent positive, or bring it to the top and make the exponent positive. Or vice versa. If it's on the top and you want to bring it to the bottom and make the exponent negative, do whatever you want. Just don't break any of the laws. Okay, so why not to flip it? 3a to the negative 2 equals, well, every time I'm going to start off with an over, a fraction. Every time I have negative exponents, I'm going to use a fraction to start off with. Now, the rule was, if I have a negative exponent, I bring the thing to the bottom and make the exponent positive. Well, again, from the few last sections, if I have a number like 3 without an exponent, I'm going to give it an exponent. Every time I get confused and I see a number all by itself, I'm going to give it an exponent of 1. So only a has a negative exponent, so all I'm going to do is bring a to the bottom and make the exponent positive. Now, 3 is sitting on the top. Notice I use perfect fractions using my graph paper or line paper all the time. 3 is sitting on the top. Leave it on the top. Now, how can we check our answer? Well, we learned that we'd have to pick an arbitrary value for a. I don't even have this in the notes. I'm just going to do it for fun. So 3a to the negative 2. I'm just going to randomly pick a equals 5 asterisk. Then I'm going to substitute 5 in for a. Then I'm going to type that into my calculator, and I'm going to get 0.12. Then I'm going to rewrite the question, 3 over a squared. This time I'm going to go to the right, 3 over 5 squared, which is also 3 divided by 25, which is 0.12. So they are both the same, therefore check mark. Continue right along. So let's take 3 to the negative 3, a to the negative 2. Well, these things both have a negative exponent. I'm going to start with a fraction. And they both have negative exponents, so I'm going to bring them both to the bottom and make both the exponents positive. And then, yeah, if there's nothing on the top, put a 1 on top. Sure, pick an a value, put it in the question, put it in the answer, make sure your answer is correct. Whatever. Down the page, open bracket, 2x all to the negative 3? Well, the whole thing, all the brackets of 2x has a negative exponent. So I'm going to bring it to the bottom and make the exponent positive. Then leave a 1 on top. Circle my answer. Go to the down, go to the right, whatever. Sometimes it looks prettier to the right, whatever. Sometimes it looks prettier down. I'm going to go to the right. So now they both have an exponent of 1 on the bottom. I'm going to give them both an exponent of 1 on the bottom. And I'm going to multiply my exponents. 2 cubed, x cubed. 2 cubed is 8. Do that. Whatever. Find out what they want. Etc. This is probably better. But lots of the times they just want you to leave it exponents. Like the last answer, 3 cubed is 27. We could have wrote 1 over 27a squared. Whatever. Circle that answer. Depends on what they asked for. So now let's just learn some theory. So I need a little space. Hopefully you're not writing as gigantic as my graph paper is. So let's learn why negative exponents happen. So let's take 3 cubed equals 27. It's not a 27. And 3 squared is 9. And start to think about patterns. Well, the exponent on the left is going down by 1. The calculation on the right is being divided by 3. So what's 3 to the 1? Well, the exponent is going down by 1 on the left. So the pattern has to continue. And 9 divided by 3 is 3. So we all of a sudden know what 3 to the 1 is by simple patterns. So let's take 3 to the 0. Well, we know we simply just have to divide by 3, and 3 divided by 3 is 1. So 3 to the 0 is 1. And on the review sheet, anything to the 0 is 1. So I'm just going to shrink that up a tad and actually need a little bit more space. So I'm going to do that again. Whoops. So now let's continue that pattern on the left and 3 to the negative 1 and say, well, what does that equal? Well, we know the pattern just continues. We have to divide by 3. And 1 divided by 3 is just 1/3. Or 1 over 3 to the 1. I'm going to clean that up. 1 over 3 and give it an exponent of 1. Look at that. We just brought the exponent to the bottom and made the exponent positive. Okay, this is fun. 3 to the negative 2 equals what? Well, start off with a fraction. We know the pattern has to divide by 3, but what's 1/3 divided by 3? Well, let's figure that out. 1/3 divided by 3, 3's over 1. Flip and multiply, 1 over 3 times 3 over 1. Cross cancel, 3 divided by 3 is 1. So 1. Okay. Excuse me. Oh my gosh. I didn't flip and multiply. Erase that. Erase that. Oh my gosh. It's going to happen. So we have 1 over 3 times flip and multiply equals 1 over 9. Excuse me. That's going to rarely happen. So we know the answer has to be 1 over 9. But what we just learned, we can bring the exponent to the bottom, make the exponent positive. So we get 1 over 3 squared. And we know 3 squared is 9, so we know the answer is 1 over 9. So we just proved to ourselves how negative exponent laws work, and it's going to much more easily allow us to understand how things work and how things are put together, and whichever. Make less common mistakes, understand why some numbers are brought down, whichever. So try and avoid flip it. Think, if you have a negative exponent on the top, bring it to the bottom, make the exponent positive. If you have a negative exponent on the bottom, bring it to the top and make the exponent positive, etc. So now let's see some more negative laws, negative exponent laws, where we can use some other rules. So let's take 5 to the 1 over 3 to the 1, and let's say to the negative 2. So I know I can multiply my exponents. So we have 5 to the negative 2 over 3 to the negative 2. And I told you that whenever I was working on a negative exponents, I always put an over. Now we have 5 to the negative 2 on the top, so we can bring that down to the bottom, make the exponent positive. And we have a 3 to the negative 2 on the bottom, so we can bring that up to the top and make it positive. Now I could say 9 over 25 and check it on the calculator, open bracket, 5 over 3, close bracket, to the negative 2. It equals the same thing, check mark. But if we do want to say 5 over 3, give both of them exponents of 1 to the negative 2. We can use the rule flip it with negative exponents like this. So you can flip it. It was 5 over 3, so now it's 3 over 5, and make the exponent positive. Then you can distribute the exponents. The exponents are exponents of 1, 3 squared over 5 squared. When you can check your answer. Excuse me, when you can flip it. Now, keep in mind, you can do things like flip it. Like earlier questions when I gave you 3a to the negative 2. And we knew that we just brought the a down. Well, I can actually think about it separately. This 3 is over 1. This a to the negative 2 is over 1. And I have a 3 all by itself. And then I can flip that and then times it back in to be that anyways. But why have these confusing flip it rules when you can just use the basics, like multiply the exponents above, and then negative exponent, bring to the bottom, make the exponent positive. And on the bottom, negative exponent, bring to the top, make the exponent positive. And simplify the number of rules you have. I don't like flip it and make the exponent positive. Okay, so let's take a look at 5 squared over 5 cubed. Now, take a look at the notes. The first one says 5 to the 2 minus 5. Excuse me, that is a 5 on the bottom. So that's 5 squared over 5 to the 5. Excuse me. So we're going to subtract the exponents, and we get 5 to the negative 3. And then we know to bring it to the bottom, start off with a fraction, and put on the bottom, make the exponent positive. Or you can just think through the theory. 5 squared is 5 times 5, and 5 to the 5 is 5 5s. You can cross off the 5s from top and bottom, and you're left with 1 over 5 cubed anyways. Or we can subtract from the bottom. 5 squared over 5 to the 5 equals over 5 minus 2 is 3, so we have 5 cubed on the bottom and put a 1 on the top. Just subtract from the bottom. Check your answer in a million different ways. Type in any of these, well, the question and all your answers, make sure all the same. Forgot to circle my answers check mark. So you can subtract from the top and then bring it to the bottom, or you can just subtract from the bottom and leave it. So below 5 squared over 5 to the negative 3. Now, a bunch of ways we can do this again. Again, we have negative, so I'm going to start with a fraction. We have 5 squared, it's sitting there. Now I have 5 to the negative 3, I'm going to bring it up, make the exponent positive, and times. Then I have the same base, so I'm going to add the exponents, 5 to the 5. Circle my answer. Or 5 over 5 to the negative 3, and then I'm going to use a division rule so I can subtract. So it's going to be 5 minus negative 3. 2 negatives side by side makes a positive, so we get 5 to the 3. Excuse me, I forgot the 2 on top. I forgot the 2 minus. 2 minus negative 3. Excuse me. 2 minus negative 3. Which is 2 plus 3. Which is 5 to the 5, same as above. Pardon me. So, there's some more examples where you can subtract from the bottom and leave it there, or whatever you want. Just don't break any of the laws. So remember, step 1 is always starting off with an over, a fraction. So if I get a question like 2x to the 5, y to the negative 2, over z to the negative 3, excuse me. Notice I slash my z's. I'm just going to start off with an over. 2's on the top. We have an x to the 5 on the top. We have a y to the negative 2 on the top. That's going to go to the bottom. We're going to make the exponent positive. Then we have z to the negative 3. It's on the bottom, so we're going to bring it to the top and make the exponent positive. So remember, start off with an over. Put anything that has not moved where it has not moved. Move whatever needs to be. If nothing is left on top, put a 1 there. Great, so that's all of our negative exponent laws. That's with numbers. In grade 10, we're going to look at variables. Let's take a look at some combinations.